So, is Aurora there? Good. Right, Aurora, we're just going into quadrilaterals. So we're looking at square, and we're saying it's got 4
Do we have to
equal sides. Yeah,
do we have to write this down?
Yeah, if you
Do
can.
we have to write this down?
Yes.
Do we have to write, I will know all about quadrilaterals?
Why not, buddy? Why not? That'd be great. Square, 4 equal sides.
4 equal angles?
4 equal angles. Well done. What do you know about those angles? Anybody tell me what those angles are?
16th of what?
What would those 4?
They're 45 degrees on the inside.
45, they are. What if I was to do this?
Are they 90 degrees?
Ah, good.
Because they're a right angle.
They are right angles. Yeah, they're all right angles here, aren't they?
Like that.
Little.
There's one right angle and another right angle, but it's just upside down.
Gosh, you guys know so much about these
I'm
squares.
just kidding.
Each angle is 90 degrees. Oh my goodness, you guys are great. Okay, I'm gonna have to make the font smaller in a minute because you guys know so much. What about lines of symmetry, people? What about lines of symmetry? Square. What do you think?
What?
You to fold it in half and then fold it in half, or how many times do you think you could get different lines of symmetry going on there in the square? 4, does someone say 4?
Yeah.
Yeah, totally right. All over that, aren't you? Yeah. 4 lines of symmetry. Oh my goodness, look at that. So that's our square. I'm going to show you some lines of symmetry. Oh, let's change it to green. As it's a square, you can fold it that way. As it's a square, fold it that way.
Okay.
4 lines of symmetry. Well done. Okay, rectangle. What do you know about rectangles?
They have 2 pairs of 2 equal sides.
Yes, they do. They have 2 opposite sides are equal length. I know that's a little bit wordy, but we're just trying to get a little bit more mathematical, but you're right. The 2 equal lengths are opposite each other. You see my lovely green arrow there? Look at that.
Yes.
Yeah.
Degrees.
I'm going to go maybe a bit of pink for this one. There we go. So these opposite sides are equal in length. Do you agree with that?
Yes.
Good. In that case, I think you're a fantastic class. If you didn't agree with me, there would be trouble. Okay. Good. So we've got 2 opposite sides equal. I know you're writing down. Aurora, could you tell me anything about the angles inside the rectangle, please? Are they the same as a square, the angles inside? Do they look the same? Yes, well done. Fantastic. So each angle is 90 degrees. So we call that a right angle, don't we? So it's very similar to a square.
But it's not a
But
square.
it's not. Why is that though? Tell me why it's not the same as a square.
Because it only has 2 lines of symmetry.
Yeah, absolutely. It can only have 2 lines of symmetry, and it only has those 2 sides, opposite sides that are equal. Yeah. So we've got our lines of symmetry here. I think I'm going to go light blue. Could you see, you could fold this here in half. Is that right, Arthur?
Yes.
And then if we folded it up here, do you think that would go to a line of symmetry? If Mr. Denton could get his angle?
Yes.
Yeah, I think you're right, buddy. Well done. So it only has 2 lines of symmetry because the line length is not the same. So it's not going to fold on every occasion. If we were to fold that across here, across this angle there, and we said, hey, Grandma, we're going to tell you that's a line of symmetry, I'm going to bet 50 cents on it, we'd lose our bet because it wouldn't fold into itself, okay? So don't bet Grandma that that rectangle is going to go that way. It won't. It'll only go that way for our lines of symmetry, all right? So it has 2 lines of symmetry. It's still a pretty cool shape. It's probably one of the most regular seen shapes in the world. If you look around your room, you'll probably see many rectangles, especially if you look over to your windows. I can see rectangles behind Aurora on the bunk bed.
A lot of rectangles.
Lots of rectangles. I can see a pillar behind Poppy that looks like it's a rectangle.
I don't have a pillar behind me. Yes, I do. Not right behind you.
Rectangles, very useful little shapes they are. We like them a lot. Okay, so we've got squares and rectangles and we know about them. Am I okay to delete this? And I can get into the difficult stuff. The stuff.
I'm still writing 90 degrees.
Oh, Mr. Denton, I can't do it. It's too difficult. And I'll be like, okay, I'm here to help. That sort of stuff, yeah? Like I did with all the triangles where you didn't know what to do, did you? You got it all right, didn't you? Right, I'm deleting the square. Sorry, square's got to go. Okay. Now I'm going to try and move that down. I'm not going to get rid of it. I'm just going to get it down there so I can draw my parallelogram, okay? Now this is not only is it a cool shape, it's got a really cool spelling. P-A-R-A-L-L-E-L. Parallelogram. Okay? Parallelogram. Always think 2 L's come together first. We've got our parallelogram. Now he's a pretty cool customer as the parallelogram. But we have to understand what parallel means first. So I'll just wait for you to write your words about the rectangle and I'll have a cheeky cup of tea.
Can I write parallelogram down?
Can do, yeah. If you're ready to rock and roll, we can do that. Okay, that one of them. So, parallelograms. What do we know about parallelograms? Well, the clue is in the first part of the parallel. Parallel means. What does it mean?
It means 2 sides are the same and 1 side isn't the same. It's a parallelogram.
Parallel means that the lines are never going to cross. Yeah, if I had this like that, eventually, if I carried that on going down here, this line here would eventually cross it. You see, they touch each other. So they're not parallel. A parallel line, think about a train track, something like that. A parallel line is where they do not meet. They never cross. So this, I could carry this on forever. I could take it all the way to Villamora and just keep extending this line, and they would never cross each other, which means they're parallel. You could probably look around. With you looking at your rectangles, you've got parallel lines.
I'm looking at my book.
Yeah. You look at your book. Book's got parallel lines.
I'm looking at my computer.
Yeah, and you'll see there'll be parallel lines involved in that. So that just means lines that do not touch. Think about your football pitch, your tennis courts. These lines around the edge, they will never cross each other. Okay, so that's parallel. So this parallelogram is a pretty cool customer because he's got two pairs of parallel lines. And when I draw it, you'll probably recognize it. You just didn't know it was called a parallelogram. So I'm going to draw my first one. And I'm going to get the lines. Now they have the same length line, like this, okay? But they are parallel, they're apart from each other. So I'm just going to do that. And then what they do is, rather than being 90 degrees, they're a little bit offset to the side, this way or this way. So they might be like that. And then they have another set of parallel lines here, like this.
Oh, yeah.
And they join like that. So it's almost like taking a rectangle and just going, do you know what, buddy? I've got these rectangles, just slightly squash you. That's what it's like.
That makes like a house roof, and if you put one on the other side, it makes like a roof.
Yeah, yeah, I see that. So you've got these two parallel lines here, which are going, say, let's say they're going up to the ceiling. And you've got this traditional set, which are horizontal ones, just going along out to the window. Okay? That's our parallelogram. Give it a go. Try and draw it. Yeah.
I do my parallelogram like that.
Okay, that's pretty good. That looks a little bit like a rhombus because the rhombus would have 4 equal sides. So you've got to make sure they only have 2 sides, the opposite sides that are equal in length. So if we have equal sides, it becomes a rhombus.
Like this?
But it looks good. Yeah, I can see clean or messy. Hold on.
I accidentally changed my virtual background.
Like this, Mr. Denton.
Like this, Mr. Denton.
Yeah, looking good, that one. Like that. Yeah.
Mr. Denton, is this good?
Very nice. So the opposite sides are equal in length and parallel. What parallel means, we are super maths kings and queens, okay? Also, interestingly enough, the opposite angles are
Are the same?
Yeah. Now, I need a little bit of explanation. So
I
I'll
did.
show you those, but you are all super up to date with your angles, so you know when I'm drawing. Let's try that. This angle here is equal to this angle here. And this obtuse angle here, excuse me, is equal to this obtuse angle here. Sorry about the wavy lines. So they're equal, and these ones are equal too, okay? And we know that because we've studied our triangles, so that we know that our opposite angles can be equal. And the interesting thing about our quadrilaterals is that the internal angles add up to 360 degrees rather than 180 in a triangle. So all the internal angles are up to 360. And we'll move on to that as the week goes on. So, parallelogram, quite a cool customer. Do we like him more than the rectangle and the square?
Yes.
No.
Okay.
I don't know.
All right.
I do.
How many lines of symmetry do you think this parallelogram is going to have then? Don't forget, you're betting 50 cents with your grandma.
2. 2.
You've lost.
None.
You've lost.
1.
You've lost.
3.
You've lost.
4.
Lost.
16,000.
Lost.
650,000.
I'll give you a clue. It's less than 1.
0.
Oh, yeah.
That's what I said.
Now, it's quite a cool one. If you have a bit of time this afternoon, try and draw yourself a parallelogram and try and get it to fold.
Sophia said 0.
Who did?
And you said it was wrong. Yeah.
Oh, sorry, I didn't hear you. I didn't hear you. Yeah, it has 0. Yeah. Try and draw one. Fold it. It won't. It will not fold into itself.
I've drawn that.
Okay, so you all lost 50 cents apart from Sophia. Okay, fine. So your grandma's all rich. Well done. No, so you've got parallelograms. Pretty cool. Now, next one we're going to do is similar to a parallelogram, but
Many are we going to do?
Can I delete this? Yeah.
Yes.
Okay. Now, this one is called a rhombus. Similar.
I've seen a rhombus before. Because it's on one of the children's programs.
Yeah.
A rhombus.
This is a bit tricky for me to do, but you'll understand it when I tell you that it's a diamond.
How do you spell rhombus?
Let me just try and draw that.
It's like a diamond shape,
It
kind
is
of.
a diamond.
Yeah, rhombus is kind of diamond shape.
So basically,
That would definitely fold twice.
ah, okay. So rhombus spelt like this.
4 times?
Now she's pretty cool because she has equal lengths. So it's like the parallelogram being squashed, but it's like taking the square and squashing it rather than the rectangle and squashing it. So it has 4 equal sides, okay? So when you get a question and say, name this quadrilateral, you think rhombus, you think diamonds, okay?
Miss Becky?
Yeah.
How do we like draw it? That each angle on the inside is 90.
When we're looking at the angles, they are not. They're not 90. No, they've been squashed. So we get pairs of angles that are equal, like the parallelogram, and they're opposite each other. And we're always going to get an acute one where we've squashed it, and we're going to get an obtuse one where it's a little bit wider. Can you see the obtuse angle in the rhombus?
Yeah,
Is it at the top or in the middle?
in the middle.
It's in the middle, yeah. Here comes our parallel again. And Arthur was correct. 2 lines of symmetry. So if we're looking at our opposite angles again, this one and this one are the same. And this one, this obtuse angle, oh, my drawing's getting good. This one and this one are the same. So Where do you think it's going to fold for alignment symmetry then, Arthur?
So what do you see the top of it and the bottom of it? I think that's going to fold together.
So
And
from this here,
yeah,
so straight down.
yeah,
Yep.
and from the side to the other side.
You smashed that. Well done, buddy. Yeah, there's our 2 lines of symmetry. Well done.
Is that all of the shapes we're doing? Because I only have one more space.
Yeah, we're going to stop.
Okay.
What I want you to do is I want you to take your time now. Draw a shape. If you can, on a piece of paper, try and cut them out. Just check the lines of symmetry.
Can I just draw it on my book?
Yeah, if you get a spare piece of paper, it's quite nice if you can get maybe a 7 centimetre length and a 5 centimetre length for a parallelogram. Then you at least have a go at trying to fold it in, and it won't work. The rhombus is a little bit harder to do. We really have our protractors so that we can do that correctly. But we can give a parallelogram a go, definitely.
Mr. Denton, can I do it on the next page?
Yes, you can. Yes, you can.
Have you got any of the ones that we've done?
Sorry, Poppy?
Can we do any of the ones we've done?